So hello guys, welcome to my YouTube channel again, and today we will be discussing this Leet Code Daily question for 3rd Feb, and the question name is Zigzag conversion. So I'll advise you to first go through the question yourself, try it yourself, give it a try, and then if you are stuck or want to know other approaches, then please go through this video tutorial, and I'll be discussing all the approaches for this question. So the question goes like this, that you are given a string and you have to arrange this in a zigzag pattern, and the number of rows in the zigzag pattern will be given to you. So there will be two things given to you. First will be the string s and the other will be the number of rows. So you have to arrange this s in the zigzag pattern depending upon the number of rows. So go through these examples. I'll be discussing this example which will make things clear. So basically this is the string given to you. It consists of all the letters from A to Z, and you have to arrange this in 5 rows. Okay, so how you have to arrange this is, first A will come, then B comes in the in the 0th row, A comes, then in the first row B will come, then in the second row C, D, E. Then after the first row is complete, then you will move to the next column and the third row. So the rows I am doing with 0 based indexing. So first A, B, C, D, E, then F, G, H, I. Then after the I, like we are done with this pattern, then after this I, J, K, L, M, again N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So this is the zigzag pattern basically. So if you look here, so it is this thing, like first go from this to this, then go from this to this, this. So it is that zigzag pattern. Okay, so this is the pattern that we have to do. And after this pattern is over, what you have to do, you have to take it row by row. So A, take the 0th row. In the 0th row you have A, I, Q and V. So first there will be A, I, Q and V. So first you have to take this, then you have to take the second row. Second row has B, H, J, P, R, X and Z. So then this B, H, J, P, R, X and Z will come. Then C, G, K, O, S, W. So C, G, K, O, S, W, D, F, L, N, T, V. This will come, and then the last column E, M, U. This will come. So at the end you have to return this particular string. This particular string is row wise characters. Okay, first you have to arrange it like this, then you have to iterate row wise, and row wise make a resulting string row wise and return this resulting string. So this is the basic question, so try it yourself. And now I'll be discussing the approach for this. So I'll be discussing two approaches, and here I'm trying out something different. So basically this question deals with a lot of formulas, so I've written the code for you so that it is better to explain using the code itself. Okay, so let me first tell you the brute force of the first solution that is possible for this question. So let me bring the code here also. So first thing first, if the number of rows are 1, then we'll directly return this string s. So this is a kind of edge case that you have to consider initially, that if you have to arrange in the zigzag pattern in just one number of row, then the resultant is nothing but the string s. So this we have taken care of. Then see, then in the first approach what we will do is we will create this 2D matrix. Okay, we will, like, this is a 2D matrix only, right? 2D array only. It is having 5 number of rows, and we'll see how many columns it is having. So basically we will, like, whatever is told to us, we will just create this 2D array, and after that we will just iterate row wise and just give the answer. So this is basically whatever is told to you, just do that. It will take extra space, but for now we'll just do it. Okay, so now the thing is, how many rows are there? So first, the number of rows is already given to you using this number of rows, num rows, this variable is given to you. So number of rows in this 2D matrix is clear, but here how many columns should I have? Like this consists of 26 characters, but here since it is arranged like this, the number of columns is not 26, it is less. So how many number of columns are there, this we have to figure out. So first thing that we can like, this is a basically pattern recognition question, like you have to understand the pattern and code it up. So first thing that we understand is, here we can break this zigzag pattern into lines like this. So we can into blocks. Okay, so if like this is the figure and this is that figure I have taken in this, so you can break this into section. Okay, section means this from top to bottom, like this is one column and this is the diagonal move. So column move plus diagonal move, I am considering one section. So this is the first section, this is one column move, like entire column, and one diagonal. Okay, and this diagonal is going till the first index, not till the 0th index. Then this is one column and this is one diagonal. So this is the second section. Then this is one column and this is one diagonal. So this is the third section, and this is the fourth section, but the fourth section is incomplete. Basically the string is over, so it is incomplete, but the number of sections we will count it as 4. Okay, so the number of sections we will count it as 4. So first, if you can see that you can see this is the first section, this is the second section, this is the third section, and this one is the fourth section. So if you consider a section, how many elements are there in a particular section? So in a particular section I am having one, like first there is a row, right? So 1 2 3, first there is a column. So in a column, how many number of elements are there in one column? The number of elements in one column is equal to the number of rows that we have. So in the so there are 5 number of rows, so here we will have the 5 elements. And here see, if you look at the diagonal, in the diagonal this one is missing, the 0th row is missing, and the n minus 1th row is missing. So there are 2 rows which are missing in case of diagonals. Rest all rows are present. 1 is present, 2 is present, 3 is present. So basically if you calculate the number of elements in a particular section, it is nothing but these account for n elements and these account for n minus 2 elements. So if I sum this up, so number of elements in a particular section, this is nothing but number of rows. So number of rows is for the column. Okay, this is for this column, and this is number of rows minus 2, because the 0th row and the 4th row are not having any element. So it is nothing but number of rows minus 2. So if you rearrange this, this is 2 times number of rows minus 2. So number of elements in a particular section is equal to 2 times number of rows, 2 times number of rows minus 2. So this is the number of sections, this is the number of elements in a particular section. So we will be naming it one section count. So we'll first calculate this. So in one section I am having, so in this example 1 2 3 4 5 6 7 8. So in one section I am having 8 elements. And what is the total number of elements that I am having? Total number of elements is 26. So we'll have one variable that will store, so we will have this in n, that is nothing but string size, and the number of elements in a particular section we will name it one section count, and we will have this formula. So total number of elements is nothing but n. So how many sections do I have to make? The number of sections will be total number of elements divided by the number of sections that I have. So this is nothing but the number of sections. Okay, this is nothing but your number of sections, and n divided by number of sections, n divided by in one section how many elements are there. This is in one element how many sections, in one section how many elements are there. So n divided by that one section count, it is nothing but n divided by one section count. this is the number of sections, so we'll name it number of sections, and this is nothing but n divided by 1 section count. Okay, and it is a seal of it because it may be possible, because see, if you do division, it is always integer division, right? So if you have 26, if you divide it with 8, it will become just 3 because there is an integer division. So but we have 4 sections here because these 2 elements are left out. So what we'll do is we'll take a seal of it. So if you consider decimal division, so 26 divided by 8 will be 3.2 or 3.1, but if you will take a seal of it, then what will be, like, it is greater than 3, definitely greater than 3. So if you take the seal of it, then it will become 4 because seal is one number more. So that is, if you take the seal, it will tell you yes, if you take the seal, it will give you one more count if there are extra elements. So if suppose the number of elements is 24, so it is nothing but 24.24 divided by 8. If you take in decimal, it will be just 3.0. so if you take the seal of it, it will be exactly 3. But if a number is greater than 24, okay, let us do 26 divided by 8, it is nothing but 3.25. yes, so 3.2 something. Okay, 3.2 something, 3.25 exactly. So if you take the seal of this, it will be 4. So you have to take the seal. And one more thing that you can do, if you don't want to use the seal function, what you can do, you can have first take number of sections is equal to n divided by 1 section count. This is nothing but that 1 section count. And if it is not exactly divisible, then increase the number of sections. Basically this is taking the seal, but manually it is taking the seal, because if it is not exactly divisible, we will have some numbers which are left. So these 2 numbers are left, so we'll add one more section to the answer. Okay, so this is that. So we have 2 variables, one is 1 section count, the other one is number of sections. Then now the ultimate goal was to find how many columns should I make. Like, we are creating a 2D matrix here, right? We are creating a 2D matrix here, so number of rows was fixed, but how many columns should I take, that was the issue. So that is why we calculated this 1 section count and number of sections. And in 1 section, how many columns are there? There are 4 columns in 1 section. 4 is because this last one is missing, right? This last one is missing, therefore it is just 4. So because see, we have it for the last column, for the last row we have an element, for the second last row we have an element, for the third last we have, for the 1th row we have, but for the 0th row we don't have an element here. So that is why the number of columns are 1 less than the number of rows. So if there are 5 rows in 1 section, there will be 4 columns. Okay, so number of columns, so in 1 section we have number of rows minus 1 columns. So the total number of columns will be nothing but num rows minus 1, that is in one section how many columns we have into total number of sections. So this is the formula for number of columns. So this we will store. Okay, so this is the math that is required for just creation of this 2D matrix. Okay, creation of this 2D matrix, in order to find the number of columns in here, this is the max required. So that is what I have done. So see, this is the base case, then we take out n, that is your size of the string. Then 1 section count stores that in 1 section how many elements are there. So it is nothing but 2 into number of rows minus 2. This we have already seen. Okay, then in number of sections will be nothing but seal of when you divide, it will take integer division into consideration. So seal will not work with integer division, so you have to typecast this n to double so that division works properly. So number of sections will be seal of n divided by 1 section count, and then the number of columns is nothing but number of rows minus 1 into number of sections. So using this, we have this number of columns. So then we will create this 2D matrix. Okay, we'll create this 2D matrix of that particular size. Okay, So and we'll like fill it with initially with spaces, like empty, we'll fill it with a empty character, space characters. Now we are to fill like this. We have to fill like A, B, C, D, E, and we have to fill all the sections. So see, how do we fill the sections? So we fill the sections like this. So we will fill it section by section. So first we'll fill the first section, then we'll fill the second section, then we'll fill the third section, then we'll fill the fourth section, till we are left with left to fill the characters in the string. Like till the string is not empty, we'll keep on filling this string, filling in the matrix. So basically, okay, so first, in order to print, we have to first fill the row, fill in the column, and then we have to fill in the diagonal. Okay, so that is what we are doing here. So that is what we are doing in, like, it is just implementation only. So I will start from 0, because every time a new section starts, we start to fill from the 0th row. Okay, see here also we start to fill from the 0th row only. So every time a new section is being printed, we start from I is equal to 0. So I is equal to 0, and j is the column. So I is the row, I denotes the row, and j denotes the column. So j starts from 0. So here we are considering 0 based indexing. So you can see that j starts from 0. So for the first section, the j will start from 0. The column 0 will be filled. So j starts from 0 and I starts from 0. So we'll first, every time, see, we'll look why we did this. Okay, first we fill the columns. So this idx is nothing but 0. So this represents the string index. So we have to fill from A first. So A will have a 0, right? The index of A will be 0, then B will be 1, C will be 2, 3, like this. Okay, so idx will start from 0. So and we'll go till we are done with printing all the strings. So idx less than n. So first we'll fill the column first. So I see how we will fill. So first we will fill this, till our I becomes equal to row minus 1, nums of row minus 1. We'll just fill in the columns. Okay, so that is what we are doing here. So while I is less than number of rows, and while if idx becomes greater than equal to n, that is the string is empty, you can directly break, because see, where we are left with this last block, right? So here there is nothing to fill. So idx will point to n. So this z is at n minus 1. So if you move one space, then the string is not left, like nothing is left here. So that is why we have to break. So if idx greater than equal to n, then break. Otherwise ARR of ij is equal to s of idx. So basically we are just filling out this. So we are filling a at 0, 0. Okay, we are filling a at 0, 0. Then what we have to do, we have to move the index. So after printing this a, we will go for b. Okay, so we'll do in idx plus plus. So idx initially was pointing to the 0, but after printing the 0, then we have to go for this b. So that is why we did idx plus plus. So and we do I plus plus. Basically every time we have we are printing it column wise, right? So if we are moving down in the column, the row will have to increase. So from 0 we go to 1, then from 1 we will go to 2, from 2 we will go to 3, then from 3 we will go to 4. So this is just the column printing, like fill the column first, then after the column is printed, then we'll go to the row diagonal. So then we go to fill the diagonal, because in every section is consisting of two things. Every section we are filling section by section, right? So every section is having one, it is having a column, and the other it is having a diagonal. So we are done printing the column, then we have to print the diagonal. So fill the diagonal. So for the diagonal, the I will start from n minus 2. See, we are done printing this a b c d e. Okay, here we are done printing this A, B, C, D, E. So these three, this particular column is over. So E is also over. Now we are left printing this diagonal. So we have to start from this F. What is the index of this F? So initially the J was here, okay. But when we come to this diagonal thing, J should be one more than the previous. So we do J plus plus. Okay, so we do J plus plus, J is equal to J plus 1, and the I should start from n minus 2. So this is where I should start. Okay, so here I starting from n minus number of rows minus 2, and J starting from J plus 1, and I, like the row, I is the row, right? So every time, see what is happening, I is decreasing. So from I is equal to 3, it is moving to I is equal to 2. Then from I is equal to 2, it is moving till I is equal to 1. So first F, then G, then H. So if we are done printing with this H, then we'll stop basically. So till I is greater than equal to 1, do the loop. Okay, and then this condition you anyways have to add, because see, idx is greater than equal to n, idx is the string. Okay, so we cannot neglect the string. If the string is empty, we have to just break, because there may be a case that you have just the half of a diagonal. So after printing half of the diagonal, you don't have any space left in the string, so then you have to just break. So this idx greater than equal to n, then directly break. Otherwise you fill that particular position in the 2D matrix and do I minus minus. See, every time I minus minus is happening, so you are decreasing a particular, after filling this, then you are going to this. So I is decreasing and the column is increasing, because if you are here, then after here you will move to here. Okay, so J is increasing and I is decreasing. So if you are moving diagonally, J is increasing and I is basically decreasing. So that is why I is decreasing, J is increasing, and idx is always increasing, because once we are done printing with this 2, we will be printing out this 3. So idx will always increase. So after you do this C, you have to go to print the D. So idx will always increase. So this is it basically. So done doing the we are done filling the column and we are done filling the diagonal. So after this loop, the J will, like, when we will break when I will become, when I is greater than equal to 0, I is greater than equal to 1, you are going here. But once you decrease, for I is equal to 1, do this loop. For I is equal to 1, if you do this loop, it will not go here, it will go for here. So it will fill the matrix and I will become 0. Okay, I will become 0 and J will become 1 more than that. So J will go here, J will go to 4. So because I am considering this example, so after you fill the first section, I will become 0 and J will become 4. So J will become 4 and it will break. So when I will become 0, it will break. So this I is equal to 0 you do not need, and if you write this, then also it is fine. If you don't write this, then also it is fine, basically, because after this loop I am going to the correct position. So after this H, I am going to this I position. So this I position is the next section which is starting. So then it will start printing column wise, then it will start printing column wise, and again it will print diagonal wise, and again then column wise, then diagonal wise. So again this will happen. So this is the basic traversal, that column wise, diagonal wise, column wise, diagonal wise, and this is printing basically section wise. So first you are done printing the first section, then the second section, third section, fourth section. So now you have the 2D array with you. Now you just have to do one thing, you create your answer and then go row wise and iterate over all the columns in that particular row. And if the aij is not equal to empty, so basically in here we'll have some empty spaces. So this is empty, this is empty, this is empty. So if that is not empty, then add that particular to the answer, because at the end we have seen that we want row wise thing, right? we have to go for first row, then we have to go for the second row, then we have to go for the third row, and so on. So we just maintain that row wise thing, row wise iterate over all the row by row, and then directly return the answer. So this is the basic solution. Okay, let us also run this. So it works, and it is submitted also, but you can see that the like time it is taking a bit more. Okay, memory also it is taking a bit more. So this is the brute force solution for this. So this is also a good solution, basically. Like this is one of the accepted solution. So yes, this is one of the solution. So what is the time complexity of this? So basically it is n into basically what we are doing is we are making a grid. Okay, so whatever is, and we are iterating over the grid, so whatever is the size of the grid, that will be your time and space complexity, because in the grid we are just iterating it 1 or 2 times. So for like this is we are iterating over the grid, and here we are creating that grid. So it is nothing but we are traversing over the grid 2 times, so it will be nothing but 2 into the size of the grid. But since in time complexity we get rid of the constant term, so it is nothing but the size of the grid. So size of the grid, if you consider the size of the grid, so number of rows is the number of rows in the grid, and this n is basically number of columns. So if you have seen, the number of columns is nothing but it is some factor of n, like the maximum number of columns that we can have is the n only. So if you consider that the number of rows is equal to 2, then you will have the size of the columns very huge. Like then you have to fit this string in just 2 rows. So it is order of n in the number of columns. Okay, so that is why the time complexity and the space complexity is n. N represents the number of columns, and number of rows it is given to you, so it is n into number of rows, and the space is also that. So this is the a brute force kind of solution, but this is also a good solution and an accepted solution. So if you understood this, then it is fine. Okay, then also it is fine. And now if you want to look at the optimized solution, so now I will be discussing the optimized solution, which will not take this grid into consideration. Like you don't have to make this grid. Okay, without creating this grid, we will directly create the solution with some pattern matching. Okay, so without creating this grid, we will do it. So now if you consider this second solution, so what we do here is, in the second solution, if you consider this now, like the second solution will also work on this sections only. Like we will divide our answer into some sections only. So it is a section by section solution, but now we observe one thing here. Now if you look in a particular section, in a particular row, so in the first section you have seen that if the row is 0, then we have just one number in here. If the row is 4, then also we have one number in here in a particular section. But if we have first row, then there are 2 numbers. If we have second row, then also we have 2 numbers. If we have the third row, then also we have 2 numbers in here. Okay, so every row except the first and the last row has 2 numbers. Now what is the index of the first number which is there? Okay, so in a particular section, if you consider now just look at, now what we will do is we'll create the answer like this. So we'll create the answer row by row directly. So from this A, I'll directly go to this I. From this I, I'll directly go to this Q. From this Q, I'll directly go to this Y. Then from this B, I'll directly go to, like, I'll just print B, then H, then J, then P, then R. Like we'll directly go to print the answer row by row. We'll not struct any grid here, but we'll print the answer row by row. So here we will need some formulas. Okay, here we'll need some formulas. So let me derive some formulas and some pattern here. Okay, so now see, if you consider this was your first section, this is your second section, this is your third section, and this one is your fourth section. So now if you first just consider one thing, first consider the difference between, consider the difference between in the A, consider the difference between this A and I. So A and I, what is the difference? So after A I have 1, 2, 3, 4, this is the 4th, 5, 6, 7 and 8. So if in the position of A, like this was your A, right? If I add 8 here, so I'll directly go to this I, because I is present 8 steps after this. So if I want to go from this A to I have to add 8. Then if I have to, similarly I can add a 8 here to go to this Q, and I can add a 8 here to go to this Y. Okay, then if you consider for this E also, then consider for this B, where to, in from this B I have to go to this J. So how many steps that I have to take? So from this B I'll do 1, 2, 3, 4, 5, 6, 7 and 8. So here also, in order to go from this B to J in this particular string, if you from this B, if you add a 8, you will directly go to this J. Okay, adding an 8, you will go to this J. From J, if you want to go to this R is basically in the next section, so you have to add a 8, and this property holds true for every row. So if you want to go from this C to K, you have to add a 8. If you want to go from this K to the S, you have to add a 8. If you want to go from this D to L, you have to add a 8. If you want to go from this L to T, you have to add a 8. From this E to M also you have to add a 8. So if you want, like in a particular row, if you want to go, if you want to go from one section to the other section, then you have to add a 8. Okay, 8 is nothing but, if the number of rows that are there are 5, then 8 can be found by this formula, 5 minus 1 into 2, right? This is nothing but number of rows minus 1 into 2. This is nothing but your 8. So if you want to go from one section to the other section in the same row, then you can directly add a 8 in this string and directly go. So this is one thing. So this is how we will go from one section to the other section. Okay, since we have to now print the answer row by row, so from the since we have to print the answer row by row directly, we are not creating any extra 2D array. So we'll directly do it like, if I want to go from this row section to this section, I'll directly add an 8. Then see, in the 0th row, if you consider, if you are at the 0th row, then you just print out this A and directly add a 8 to go to the next section. If you are at the 4th row also, print out this E, directly add a 8 to go to the next section. So this is valid for the 0th row and the n minus 1th row, like the 4th row. But in some other rows, you have to have you have to print 2 characters. Okay, one is this character and the other is this character. Then here also you have to print this character and then this character. Then here this character and then this character. So now how to go from one character to the other character? So earlier this formula we have seen, this formula is to go from one section to the other section. But if I want to go in the same row in my section, like in my section there are 2 values, so how to migrate from this 8 to this H? So now there is one more observation. So this is an observation based problem. So from the observations I am creating formulas. So if you are at the first row and you want to go from B to H, you have to increment by 6. So see, B, then C, 1, 2, 3, 4, 5, 6. So if you increment by 6, you go to this. Now if you are at the 2th row, like if you are at the 2th row, then if you want to go from this C to this G, then see, 1, 2, 3, 4, you have to increment by 4. If you are at the 3rd row, then if you want to go from this first to the second, you have to increment by 2. So just look at the formula here. If you are at the first row, you have to increment 6 times. If you are at the second row, you have to increment 4. If you are at the 3rd row, you have to increment 2 times. Okay, so here we have this thing that if you are at the first row, you have to do it 6 times. Okay, so 6 you can write as nothing but 6 is nothing but 3 into 2. 6 is nothing but 3 into 2, and 3 you can write 3 as 4 minus 1. Similarly, for 2 we were supposed to go 4 times. Okay, for 1 we were supposed to do it 6 times. For 3 we are supposed to do it 2 times. So this 4 you can write 2 into 2, and this 2 you can write 4 minus 2. For this 2, for this 3th row, you wanted to increment 2 times. Okay, 2 you can write 1 into 2, and 1 you can write 4 minus 3. So number of characters to skip is nothing but this 4 is nothing but number of rows minus 1 minus whatever is your current row. If here the current row is 1, see, current row is 1, current row is 2, current row is 2, current row is 3, current row is 3. So if you wanted to go from this from the first element, you wanted to go to the second element in the same section in the same row, then you have to apply this formula, number of rows minus 1 minus the current row into 2. Okay, so these two formulas will only help in order to get the solution. So first formula is how to get, so I am writing the two formulas needed for the optimized solution. So there are two formulas. In order to go from one section to other section, like in order to go from one section to other section, you have to add 8. 8 was nothing, number of rows minus 1 times 2. So this is to go from one section to other section in the same row, and then this formula is, this second formula is like number of steps, number of characters to skip. These characters we are skipping in the original string. Okay, so now skip in the original string, idx basically. So number of characters to skip in the original string to go from one character to the second character in the same section in the same row. So this is that formula used. Okay, so after doing this, now we are ready to implement the optimized solution. These are the two formulas used here. So yes, so now just consider the code. Okay, so this is the edge case. If the number of rows is 1, then we directly return the original string. Then we take n is nothing but s dot size. So s dot size, like basically what is the string size. Then this is not needed here, this is not needed. Then we directly have this answer, and we then iterate over all the column by column. Right now we are iterating just column by column. So for the 0th column, then for the first column, then for the second column. So the column will go then for the first row, so we will be iterating rows, right? 0 row, 1 row, 2 row, 3 row, and the 4th row. So 0 rows will start. This I is your current row, basically which row you are considering. So this is nothing but your current row. So current row 0. Okay, so we'll start from the 0 row and go all the way till all the rows, and see in the first row this A. Okay, so whatever is your row, this first character will be that index. So A was having at the 0 position, then this B, okay, this B is at the first position, so, and the row number is also 1. C is at the 2th position and the row number is also 2. D is at the 3 position in the original string and the row is also 3, and this E is at the 4th position in the original string, and in the row number also this E is at the 4th position. So IDX at a particular row in the string, the IDX will start from I. So IDX is the original string index, okay, original string index. Then now we have to go till like print that particular, go to section by section. So here we'll be having a loop for the sections, and the breaking condition that we are done is when the IDX will exceed the n, we'll break. Now we are ended, like all the sections are over. So that will mean that the sections are over because the IDX has moved out of the range. So the first character is nothing but s of IDX, because every section has one character at least, okay. So the first character is nothing but s of IDX. So as soon as we get the first character, we add the first character to the answer. And if I is the current row, so if the row is not 0 and the row is not the last row is nothing but nums row minus 1. So if we are not the 0th row and we are not the last row, we will have one more character. So that is why this if condition. So that means that we have second character. So if I is not the case, we have the second character. So inside the second character, we first find the index of the second character. So currently we are at IDX. IDX was supposed 2. So we derived the formula how to go from this. So we were at this B, right? B was having an index 1. So how to go from this 1 to this H? So we said that in order to go from number of characters to skip in the original string IDX, to go from one character to the second character in the same section in the same row, we have to use this formula, okay. So this is current row is nothing but I. So we have used a similar formula here. Second index is given by IDX plus, so we have to increment in this IDX. So suppose you are here, you are at the J position, J is having some index in this, okay. So J is having some index, so how much to increment to go to this P in the original string? You have to go till incremented by 6, right? 1 2 3 4 5 6. So you have to do a plus 6. So how to get this plus 6? This formula tells us. So IDX plus nums rows minus 1 minus IDX into 2. This is that formula, okay. Num rows minus 1 minus I into 2. And if this second index is less than n, so we have that thing in the string. So we take out the second character as s of second index and we add it to the answer. Okay, so this is for the second character. And so this is for the section by section over. Okay, this is row, this is iterating over row, and in a particular row we are moving section by section. So this while loop is for section by section. So how to move from, now we are done with a particular section in here, but how to go from the first section to another, how much to increment in this IDX? So in order to go from one section to another in the same row, we have to go num rows minus 1 into 2. We have to increment it by that. So index is equal to index plus 2 into num rows minus 1. So this is that formula, 2 into num rows minus 1. So IDX is equal to IDX plus that, and that is done. So we are done for all the rows, and in all the rows we are done for all the sections. So this is it, and directly you return the answer. So this is the optimized approach for this. Okay, I'll advise you to also go through this dry run over this case and how things are changing. Okay, so just take this solution and dry run over this. You will understand better. And yes, talking about the space and time complexity for this, so we are just going to all the character one time, like from A we are just going till I, from I we are directly going to Q, from Q we are directly going to Y, then from B we are directly going to H, directly going to G. So every character in the string is traversed just once, so that is why the space complexity is O of n here, and the time complexity is O of n here. And this answer string, we are not creating any 2D loop 2D matrix here. Okay, so this answer string we are using as space, so this answer string will be of size n, so the space complexity we can say that it is O of n. So here the time complexity and the space complexity is both O of n. So we have optimized from this n into number of rows in terms of space complexity also, and in terms of time complexity also. We have reached this O of n solution in both cases. Okay, so this is it. These are the two solutions. Go through them, dry run this and try to understand this. And yes, this is it for this video. So if you like the video, please comment, subscribe my channel, and if you have any doubts you can ask in the comment section, and also follow my LinkedIn page, Instagram page. All the links are in the description, and I'll also attach the link of this doc in the description. So if you have doubts in the code, you can refer here. The solutions link will be also attached in the description, so follow from there. So yes, that's it, and see you in the next video.